Under acid, base, and salts, we talk about properties, chemical properties, and preparation of acid, base, and salts. We talk about acid.
Okay.
Then you taught us bases and alkalis. We should talk many things under it. We talk about the properties and chemical properties of bases and alkalis, the preparation. We stop at the preparation of the we stop at the preparation of as bases and alkalis. That's where we stop.
Okay. Khadija, okay, thank you very much. But I would like to ask you a question on that. So, okay.
Okay,
We
sir.
did pH, right?
Oh, now.
Have you seen the message at the inbox? You have a message, Khadija, that you should
Okay,
type in
sir.
your name. Yeah, what's your name? What exactly is your name?
My name is Khadija Ali.
Khadija Abi. Yeah, type it at
Now,
the message inbox there. Drop your name at the inbox. Okay, Khadija. Okay, that's good. So, fine. You try on that. Okay. Any other person before we proceed? Amida Dosunu. I knew that you are with us. What actually we are doing, you don't know what we are actually doing today. Why I keep asking you a question. You want to infer something from it. Okay. I'll be calling names now. Okay. Amida Dosumu. Okay, Lawal.
Sir,
Yeah. Lawal Rodia. Continue, please.
Assalamu alaikum, sir. We talked about acid, types of acid, basicity of an acid, um electronegativity elements, physical properties of an acid, chemical properties, uses of acid, base, physical properties, how to prepare, preparation of base, and we stopped at pH and
Thank
POH.
you very
But
much.
we've not
Thank
done
you very
calculation.
much. Thank you very much for that. Okay, let me just ask you a question regarding the pH there. Can you help us to define the pH that we actually did in our last class? pH, the pH we did. Okay, what's the definition? What definition do we give the pH exactly
Is the negative logarithm of the hydrogen ion.
of the hydrogen ion? Continue.
Base 10.
To base 10. Thank you very much. Okay. Drop your hand, Lawal, Rodia. Okay, the next person is Amidat Dosumu. Continue from there. Amidat Dosumu, I would like to ask you a question. I have a lot of questions with me here. Do you understand? So
So,
I have a lot of questions. Okay.
okay, sir.
Continue,
So
please.
we start at acid, base, and salt. So you define acid for us. Acid as we have different type of acid: strong acid, organic acid, mineral acid, stuff like that. And you said there. I said weak base. Yeah, there is weak base. So basicity of an acid. It refers to the number of hydrogen ion in one molecule of an acid. So you give us an example of 2HCl. So that the basicity of that has two hydrogen of atoms of hydrogen. So we move down to base. And the day two, we talked about basic of acid, which you said that means basic of an acid means acid of metals. And you said NaOH as strong acid and POH.
Okay.
So I said physical property of acid. It's alkali. It turns red. It must paper blue. Have soapy smell or feel. I
Okay.
said I gave us clinical property of base, which is alkali. B, yes. So we go to, I think it's pH. So and you said pH means potential of hydrogen, while pOH means potential of oxide.
Okay,
I
thank you
said
very much.
acidic. Okay, sir.
Go on. You want to say something? Go on.
Acid increase from left side, while base increase toward the right side.
Okay, that's pH scale. Exactly. Okay. Risco Ademola, continue.
We did base and alkalis. First of all, definition of base. A base is a substance that neutralizes an acid to form salt and water. And base may be soluble in water and also may be insoluble. And we have example of bases: zinc oxide, that's ZnO, copper oxide, CuO. And we did alkalis. Definition of alkalis: an alkali is a base that is insoluble in water, and it also produces hydroxide ions, that's OH minus in solution. We have example of alkalis. We have NaOH,
Before you proceed,
KNaO. Nam?
hello, before you proceed, you said alkali, they are insoluble in water, right?
Yes.
Are you sure of what you're saying? They are insoluble in water, are you sure? Example is sodium hydroxide, that's sodium hydroxide pellet, right?
Yes.
Is sodium hydroxide pellet soluble in water or not?
They're insoluble in water.
Then why will you now say alkali are insoluble in water? So that statement, do you understand now?
Yes, sir.
Okay, continue with what you're saying. Continue.
And we also did indicators. We have
Okay.
litmus, material range, and universal indicator. We did litmus, it's acid, it is red. In alkali, it is blue. Methyl orange, red. In alkali, it is yellow. While universal indicator, it is red and orange, but in alkali, it is blue and purple. We also did pH.
What do you mean by what do you hello? What do you mean by universal indicator? What do you mean by that universal indicator? What
What do you
actually
say,
do you
sir?
mean? You said we talked about universal indicator in our last class. What do you mean by that universal indicator? You know, you said, okay, I can't hear you very well, though.
Universal indicator. Can you hear me now?
Yes, yes,
Okay.
yes.
It's also a mixture of indicators among the pH of the solution.
Mixture of indicators.
It's also among the
Okay,
indicator.
continue. Continue.
And we also did pH. You said the full meaning of pH is potential hydrogen, while we did pH and pOH. The full meaning of
Okay.
pH is potential of oxide.
Potential of oxide or potential of hydroxide.
pOH. Okay. Hydroxide.
Yes, potential of hydroxide. Okay. Thank you very much for that. So we really appreciate you. Thank you so much. So,
And using
okay, continue. You want to say something?
yes, use of pH. It is used to measure how acidic or alkaline a substance is. That's its use.
The acidity or alkalinity of the substances. Okay.
Yeah.
One more question for you. One question for you. Can you hear me, please?
Yes, sir.
If the pH of a sample of vegetable soup, if the pH of a sample of vegetable soup was found or was measured to be 6.5, 6.5.
It
How
is
is
neutral.
the soup? wait. If the pH of a sample of vegetable soup, I mean, was found to
Yes.
be 6.5, how is the soup likely to taste? How will the soup likely to taste? You know, we said something about the taste board in our last class, right?
Yes. Yes.
Now, if you have a vegetable soup now and the pH
Yes.
of that vegetable soup was found to be 6.5, do you understand now?
Yes.
What will it be the taste? What does the taste likely to be?
The taste will be like water.
It will be like water,
Yes.
6.5.
6.5 is neutral.
6.5 is neutral. Are you sure?
6.5 zero to
No.
which one is talking?
Okay. I will call another person. Amidat. Amidat Dosumu.
Sir.
Now, assuming we have a soup now, we have a vegetable soup. And
Yes,
when
sir.
we measure the pH of that vegetable soup, it was found to be 6.5. The vegetable soup was found to be 6.5. How will the taste likely to be?
It is
It is the taste. Yes, it is acidic. It is
yes.
acidic.
Yes.
Yes.
Yes, we know that it is acidic. Is it strong acidic or it is weakly acidic? Strongly
Is it
acidic
what?
or weakly acidic? Is it strongly acidic or weakly acidic?
Weekly acidic.
Weekly acidic.
It's
Weakly
Weekly
weekly.
acidic.
acidic.
And
Yes.
when we talk about acid, what do we said about the taste of an acid?
Acid.
Yes.
So,
What do you say? Someone said something now.
salt taste.
Salt.
It has a
It is
sour taste.
salt. Salt. Thank you very much. It is weakly acidic and it is what? It is salt. Okay. Thank you very much for answering the question. Okay. Now, my question goes to Ajibade Atia. Now, the question is the sodium hydroxide, we said, is it delicquescent or hygroscopic? Sodium hydroxide. Sodium hydroxide.
Sodium hydroxide is hydroscopic.
It is hygroscopic. Are you sure it is hygroscopic? I don't expect that answer from you.
Sorry, sir. Sorry, so sorry about that. It was a no. Sir, it's hydroscopic.
It is hygroscopic. Okay, fine, you get it, but I don't expect that answer from you. Okay, let me call down Rakib. Adebimpe Rakib. Adebimpe Rakib.
It is also deliquescent.
Yes, sir. It's delicate.
It is delicquescent. I don't expect that answer from you. Any other
It is
person?
hygroscopic and also deliquescent.
It is what?
It is hygroscopic and also deliquescent.
It is both delicquescent and what? And hygroscopic. Do you get it now? That's the answer I expect from you guys.
Okay, sir. Thank you, sir.
Okay. Now another question I'm going to ask you, Rakib. Adebimpe Rakib. I will ask you another question. Should I proceed with my question?
Okay, sir.
Mo ti rọra sọ fún tẹ́lẹ̀ pé kò sóúnjẹ kankan lọ bá àǹtí ẹ̀. Ó dẹ̀.
What do you think will be the color of litmus paper when put inside ammonium hydrate, ammonium hydroxide? Sorry, ammonium hydroxide. What will be the color, or what color will it change to when a litmus paper is put, or when the, let me put it this way. Okay, what will be the color of litmus paper in a solution containing ammonium hydroxide? Let me put it that way. It's a logical question. Okay, Yusra Lawal, what will be the color?
It will be blue.
I said it's blue. Why do you think it will be blue?
Because ammonium hydroxide is basic.
Is the base. Thank you very much. And what do we put inside the base to turn to blue?
Red litmus paper.
Red litmus paper to blue. Thank you very much for that. Okay. Okay. Ali Idayat, this is your question. Okay, assuming we have 4 different solutions. 4 different solutions. Solution A, B, C, and D. Solution A, B, C, and D. And these 4 solutions were measured using pH, and their number are as follow. Their number are as follow. The first one, which is A, solution A, was measured to have a pH of 11. YB was measured to have a pH of 5. YC was measured to have a pH of 7, and the last one was meant to have a pH of 2. So now all of them were now mixed together. Are you getting the question? Did you get the question right? Ali
Yes,
Daya.
sir.
Okay.
Yes, sir.
All these solutions, all these elements, all the solutions were mixed together. Can you predict the nature of that solution? Will it be acidic or basic? We have 4 different solutions. We have solution A, B, C, and D. The first one is 11. It has the pH of 11. The second one has the pH of 5. While the third one has the pH of 7. While the last one has the pH of 2. pH of 2.
Okay, basic. 11.
Basic. Basic.
It will be basic.
Yes.
Yes.
All of
11.
them are mixed together.
Yes.
Are you sure it is basic? When all of them are mixed together.
Huh.
We have 11. 11. Is 11 a strong base or weak base?
Strong.
Strong.
Basic.
Are you sure it is strong base?
Yes.
Yes.
Okay. What of 5?
Acidic.
Is it strong acid or weak acid?
Strong.
Stronger. Weak acid.
5.
Weak
It is
acid.
Weak.
acid,
Weak.
right?
Weak. Right.
What of 7?
Neutral.
7 is neutral.
Neutral.
What of the last one is 2? What do we have for 2?
Acidic.
Acidic. What acidic?
Strong.
Strong acid. But that acid that is strong is more than the strong of that base, Abi, because it is from 7 to 14. The base that we have there is 11, right? Which is slightly strong. It is not that strong, but what? Slightly strong. The one that is strong starts from 12.5 to 14. Do you understand? So slightly strong. But out of the two that we have, which is the strong acid, strong what? Strong acid. It is highly strong. Are we together? We have the neutral. That shows that we have two different acids there. We have the strong one, we have the weak one. While we have the slightly strong base and the neutral. What will now be when we mix everything together? What do we now think will be the nature of the solution? Will it be basic? Will it be acidic? Will it be neutral? Will it strong acid?
Acidic. Strong.
It is not strong acid, it is acidic. It is what? Acidic.
Acidic.
Because we have, yes, if you predict it, it will be strong acid because we also have slightly strong base, and we also have a neutral. Do you understand? So if perhaps that we have two different strong acid, so that's when we can have strong acidic. Are we together?
Yes, sir.
I think, are we getting it?
Yes, sir.
Okay, that's fine. Any other person that is there? Do you have any other person that is there that we can ask a question from? Do you have any other person?
Muslim Khalid is there.
Okay. Muslim Khalid. Okay.
I'm the one that said I wasn't in class last week.
Okay. Taufik Khadija.
Yes, sir.
Are you with us?
Yes, sir. Sir, I would like to say something, sir.
Okay.
I also just joined the class, but I would like to try the question. I would like to give it a go.
You like to do what?
I would like to give it a go.
You like to, I can't hear you perfectly.
I would like to give it a go. I would like to give the question
Okay,
a
you
go.
want to give it a go. Okay, that's good. That's good. Okay, let me just ask you this question.
Mo padà wá charge ẹ̀, but mo ṣe tàn sílẹ̀ mo máa ń dúró de.
Hello, you mute your mic.
Student charge you.
You mute your mic, please. Ali Dayat, mute your mic, please.
Ó wà ní.
Mute your mic.
Okay.
Oh.
Okay, the question goes thus.
Hey, tell her to mute herself now.
Basicity of an acid. We said something about basicity of an acid. Now, if we have propanoic, do you know propanoic? Can you write it?
Yes, sir. I can write
Taufik,
it down.
you can write it, right? You know propanoic.
Yes, sir.
Propanoic.
Yes, sir.
What is the basicity of an acid in propanoic?
Basicity of an acid.
What is the basicity of an acid in propanoic? Propanoic acid. Propanoic, is it monobasic? Is it dibasic? Is it tribasic? Is it tetrabasic? Is it pentabasic? Or what?
Monobasic, sir.
What do you call it?
Monobasic.
How do you know that it is monobasic? Why is it monobasic? Don't worry, those people that raise up their hands, you are going to answer the question.
The basicity of propanoic acid is 1.
Why? How? How is it 1? Propanoic. Explain to us how it is 1.
Because the number of of I'm promise the number of
Okay.
hydrogen atoms. What's one? Um, the number of the ionization visible hydrogen atoms of an acid can donate per molecule.
Okay. Is that your answer?
So yes, sir.
Are you reading from AI?
No.
Okay. No problem. Okay. I'm still coming back. Don't worry.
Okay,
Okay.
sir.
What someone raised up his hand then. I couldn't remember the name. Okay, Ali Daya, you raise up your hand, but someone also, okay, Adebimpe. Is it Adebimpe Rocky? Are you
No,
the one?
no, I did not raise
Okay.
my hand though. No, I able to answer. How do that?
Okay, who want to answer the question? Ali Dayat.
The number of replaceable hydrogen ions is 1. COOH. That's H at the end, not the ones attached to the first
Okay.
carbon
Okay.
set of carbon.
I understand you. Very correct. Correct. Both of you, you are correct. So, but you need to understand something I said in our last class, that we have the functional group, which is COOH. And the COOH, the functional group, is the one that has the hydrogen ion. Like you said, ionization hydrogen. So the one that has the hydrogen ion is the functional group, not the numbers of hydrogen in propanoic. If you are to write propanoic, who can tell me the formula for propanoic? Propanoic.
C3CH2COOH.
C3,
CH3.
propanoic. Propanoic. I'm not talking about ethanoic. Propanoic.
Oh.
Propanoic.
C2H5COOH.
C2H5COOH. So that's the propanoic. So that's fine. Thank you very much for the question. So now, do we have any question before we proceed? Do you have any question? Another person has a question? Okay. In the absence of, okay, Khadija, what's your question?
Please, I want you to explain pH.
I will explain now. Okay.
Okay, fine.
Who else again? Any question? No question.
Yes, sir.
So,
Sir.
Sir,
okay, continue. Adebimpe Rocky, if you want to talk.
can you explain that strong acid and weak acid again?
Okay, the strong acid and weak acid again.
Yes, sir.
Okay,
Answer.
Ajayi. Okay, Taufik.
Can you explain more about that propanoic acid?
Ethanoic acid, propanoic acid. Which one?
Propanoic.
Okay,
The one
Ajayi. Ajayi
Okay, sir.
Abdullah. Okay.
Okay, sir. That litmus paper to blue, litmus, I don't understand it very well, sir.
Okay. Okay, who else again? Benibeko Aja. Okay, Adeniyi.
Please, sir, can you please explain more about the deliquescent and hydroscopic, like the
Okay.
soluble one and insoluble? How can we really differentiate? Because the
Okay.
last class you said not all hydroscopic are deliquescent. And not I think that's how you said it, that not all hydroscopic are deliquescent and not all deliquescent are hydroscopic.
Oh,
I
no,
don't
no,
know.
no, no,
All
no, no,
the
no, no,
deficiencies
no.
are hydroscopic. All deficiencies are hydroscopic.
Yes.
Answer.
So
Sir.
I maybe you should just explain more about it.
Okay. Now,
Sir,
Vic
what about
Odija.
efflorescence, sir?
What about
Efflorescence.
a fluorescent? Okay, we are still going there. So I just explained that in our last
Okay,
class
sir.
when we are dealing with base. So that's why I explained that. Okay. Madinat, Layemi, your question.
Can you explain more about basicity of an acid?
Okay, okay, fine. Okay, no question anymore. Yeah, let's put our arms down. Okay, before we proceed, so let me just start it from where we stop. So sorry, let me just start it from the lower ones. So which is the basicity of an acid? When we say the basicity of an acid, how do we define it? Who can help us with the basicity of an acid that we defined in our last class? Who can help us?
Basicity of an acid refers to the number of hydroxonium ions which one molecule of acid is capable of producing in an aqueous solution.
Okay, not without wasting much of our time. Okay, listen to me perfectly. So when we define an acid, we said an acid can be defined into two different definitions. So we said number one, an acid is a substance when dissolved in water. An acid is a substance. Let's listen. Let us listen. Let's listen to it very well. So an acid is a substance. When dissolved in water, it produces an hydrogen ion. It produces what? An hydrogen ion as its only positive ion. The second one is that an acid is a substance that produces an hydroxonium ion. That is that it is in two forms. Either it produces hydrogen ion or what? Hydroxonium
Ion.
That shows that you can define an acid in two different ways. But the one they prefer most to write down in your exam or when you are doing your jam, they prefer you defining an acid in terms of hydrogen. In terms of what? Hydrogen. But if you couldn't found the definition of an hydrogen ion there, if you found that of the hydroxonium ion, you pick what? Hydroxonium ion. Are we together?
Yes, sir.
Yes, sir.
Are we together? In that case, yes, thank you very much. So for that, now let's now move to the basicity of an acid. When we said basicity of an acid is the numbers of hydrogen ion. Is the what?
Is
Numbers of what? Hydrogen
ion.
ion present in one molecules of an acid. Present in what? One molecules of
molecule.
an acid. For example, when we are dealing with it, we said when we have H2SO4, when you have H2SO4, the first thing is that you first break it down into ions. When you break it down into ions, electropositivity and what? Electronegativity. Are we together? So what is electropositivity in this?
Yes,
What's electropositivity? We have hydrogen ion, right?
Yes.
Yes, hydrogen.
And what of the electronegativity? The electronegativity that we have SO4 2 minus, right?
Yes.
Is the equation balanced?
No.
No. How are we going to balance it? So we have
In
two
front of
atoms of hydrogen.
Yes.
We have two atoms of hydrogen here, but we have one hydrogen here. To balance it, we need to put two in front. That's why we have 2H plus, right?
Yes,
Are we
sir.
together?
Yes, sir.
Out of the sulfur that we have here is 1. We also have 1 here.
Yes.
Sulfur that we have here is 4, or oxygen that we have here is 4. And we also have oxygen, 4 oxygen, right?
Yes, sir.
Yes.
Are we together? Now,
Yes,
in this case,
Yes, sir.
we have the numbers of hydrogen ion present here is +2. It is what? Plus 2.
That's good.
Because here we have +1 here, right? Invisible
Yes.
1. Are we together?
Yes, sir.
We have invisible 1. But due to the fact that it is an ion, the numbers of mole that present in an ion is also referred to as the numbers of ion. The numbers of molecules, we have 2 molecules of hydrogen here. Are we
Yes, sir.
together? The numbers
Yes,
of
sir.
Yes, sir.
the numbers of ion, the numbers of molecules or numbers of mole of hydrogen ion that are present here is the same thing as ionization number, which is plus 2. Are we together?
Yes, sir.
Now, for example, if we have 2 here, if they ask you that what is the numbers of ion that we have here, it will now be 2 times 2, which is what? Minus 4. Are we together?
Yes, sir.
Yes.
Yes, sir.
These 2 multiply by these 2. 4. Likewise, here
Minus 4.
it is invisible 1. That is Are we together? Okay. In this case, the numbers of ion in these 1 molecules of an acid, it is 2. It is what? It is 2.
2.
So we can now say the numbers of hydrogen ion here is plus 2. In that case, and 2 in chemistry, it is di, right?
Yes, sir.
If they now ask you,
Yes, sir.
what is the basicity of an acid in this case, we call it dibasic. What do we call it?
Basic.
Are we together? Because it is 1. Let's give it one example more. When you have HCl, hydrochloric acid, HCl, when you break it down into positivity and electronegativity, what are we going to have? What are the H?
Hydrogen. H plus. Cl minus. Cl minus.
Minus, right?
Yes, sir.
Are we together? In this case, is the equation balanced?
Yes, sir.
Yes, sir.
The equation is balanced, right?
Yes.
Now, how many mole of hydrogen ion do we have here?
1.
1. What is the ion here that we have here? 1 as well, Abi?
Yes.
1 times 1 gives you what? 1. The numbers of hydrogen ion present here is plus 1. Are we together? In that case, and 1 is what? Mono. Abi?
Yes, sir.
1 is what? Mono.
Mono.
In that case, now in terms of basicity of an acid, we call it monobasic. What do we call it?
Monobasic.
Monobasic.
Are we together?
Yes, sir.
That's what we have. So exactly, that's what we called basicity of an acid. Are we together? Taufik.
Yes, sir.
Taufik, are you with us?
Yes, sir.
Hope there is no problem about it.
No, sir.
The person that asked the question, hope there is no problem anymore.
No, sir.
No problem. Thank you very much. So that's what I will get it. So let's proceed to the second aspect of it. So someone said, how do we get litmus paper? That question, litmus paper to red and red to blue. Now, part of the characteristics of an acid, when we said something about acid, we said acid turns blue litmus paper to red. Blue litmus paper to what?
Red.
To red. That is an acid. Acid turns blue litmus paper to red. While base turns red litmus paper to blue.
Blue.
Are we together? Just go and read the characteristics of an acid. And we now said something, a litmus paper is put inside ammonium hydroxide. Inside what? Ammonium hydroxide. And we know that ammonium hydroxide is what? Anything hydroxide is a base, right?
Yes.
Khadija, please mute your mic, please. You want to talk, just mute your mic. All right. So when we were talking about it, we said ammonium hydroxide, due to the presence of hydroxide there, it's a base, right? But we said it is what? It is alkali. Are we together? Now,
Yes,
what kind of litmus paper will you put inside ammonium hydroxide to change? What litmus paper?
Red.
Red litmus paper. And when you put red litmus paper inside ammonium hydroxide, what will it change to?
To blue.
Blue.
To blue. Are we together? So it's just a technical
Yes,
question that you need to understand. So that's how it goes. Are we together? So someone
Yes,
also
sir.
asked a question. Someone also has a question regarding delicescent and hygroscopic. So in our last class, that shows that you need to go and watch back what we did in our last class. So in our last class, we said sodium hydroxide, we are on base. We now said a base is a substance. When dissolved in water, it produces what? Hydroxide ion. Yeah, that is as its only negative ion, right? So we now said sodium hydroxide, like an example. I gave you that the most common ones that you use in titration for base is sodium hydroxide pellet. And I showed you how the color it is, how color, or don't let me say color, the size of that sodium hydroxide pellet. Let me see if we can get it here. Sodium hydroxide pellet. Sodium hydroxide pellets. So sorry for that. I think we have the issue. It is just, it looks like a button. We have what we call nylon button. Those people who are doing tailor among
Yes, sir. Fashion designer.
you guys who so this is it. Let me just show you. This is the picture. This is actually the picture. Sorry for that. So this is the picture. So could we see it perfectly? So this is sodium hydroxide pellet. You see that it just look like a button, the nylon button that they do put in our school uniform cloth. So that's how it is. This sodium hydroxide pellet, and this sodium hydroxide pellet, as we are talking about, it is just like when we expose it into the atmosphere, it gradually turns to moisture or solution. Are we together? Are we together? This, when you expose it to the
Yes, sir.
atmosphere without adding any water to it, it's what? It's just melting. It what? It turns to what? Solution. When exposed to atmosphere,
Moisture.
it turns to moisture or solution. And when we said something exposure to the atmosphere, it turns to solution, we call it delicescent. What do I call it? Delicescent.
Delicescent.
Yes. Now, we now said hygroscopic. Hygroscopic is that when exposed to the atmosphere, it becomes wet or moisture. But the delicescent, it turns to what? Solution. Are we together?
Solution.
Before we can go from delicescent, before all these substances, they go into delicescent, they will first pass the stage of hygroscopic. That is why they said all delicescent are hygroscopic.
Hygroscopic. Yes, sir.
But not all hygroscopic are delicescent, because
Delicescent.
there are some hygroscopic that they cannot turn to solution. So far they cannot turn to solution, we said they are not what? Delicescent. That's why we said not all hygroscopic are delicescent. Okay, someone said, do pellet as, let me just read the question at the message point. Okay. That pellet have another color or it is only white? The one that I've ever seen in my life, see, it is white. The one I've ever seen in my life. You see that they even package it. The one I've laboratory chemistry practical for more than that's 20 since 2015, so that's more than 10 years. So I've never seen anything like that before. So that's fine. So that's why we said all delication are hygroscopic, but not all hygroscopic are what? Are delication. Are we together?
Delicate. Yes, sir.
Okay, all delicate are hygroscopic, but not all hygroscopic are what? Are delicate. Sorry. So that's yes, that's what we mean. So in that case, so we've answered that. The next one is the pH. When we said pH, we all know what we mean by pH. We defined it in our last class, right? We said
Yes,
pH is a
yes,
substance. pH is defined
negative
as what?
logarithm.
As negative logarithm of
Negative
hydrogen ion to what?
of hydrogen ion to base 10.
Base 10.
Base
Now
10.
let's now write the different formula that we have. So now, anything that you found that it is aqueous, it means it must undergo what we call concentration. What do I call it? Concentration.
Concentration.
Yes. Now, anywhere you found something like molar, what do I call it?
Molar.
It means they're actually talking about concentration. They're actually talking about what? Concentration. Now, and when they talk about concentration, you need to take note of two things. You need to take note of what? Two things.
Two things.
They will be talking about the mole of that substances and the volume of that substances. Mole of that substances and what? And the volume of that substances. That's why in mole concept, we have what we call molar concentration. We have what? Molar concentration. This molar, it means we're actually talking about mole. We're actually talking about what? Mole. So, and when you see concentration, they are talking about volume. They are talking about what? Volume. That's why the formula for molar concentration is mole over volume. Mole over what?
Volume.
Are we together?
Volume.
Yes, sir.
Are we together? And the SI unit for mole is mole, M-O-L, small M-O-L. Are we together? In chemistry, your volume is actually measured in dm cube. What do I call it? dm cube. That's why your molar concentration has the SI unit of what? Mole per dm cube. Are we together?
Yes, sir.
Are we together?
Yes,
Now,
yes.
when you add about mass concentration, mass, they're actually talking about two things as well. Abi?
Yes, sir.
They are talking about the mass and they are talking about concentration. And the concentration is the same thing as what? What do I call it for you?
Molar.
When you add concentration, they're actually talking about what?
Molar.
No. They are actually concentration. They're actually talking about volume. That's why mass concentration, we said, in mass concentration, the formula is mass over volume. Mass over what? Volume.
Volume.
And what else I need mass in chemistry?
Kilogram.
Is it kilogram or gram?
Yes, I
In chemistry,
gram.
But in your physics, they do measure mass in kilogram. But chemistry, when they give you in kilogram, you need to convert it to what? To gram. That's why the SI unit for mass here is gram per dm. Are we together? So this is actually what you need to know about that. So now, when you had the word ion, for example, H plus, and they give you a value for it. In that same note, they're actually talking about concentration. They're actually talking about what? Concentration. What that concentration they're actually talking about is molar concentration. Is what? Molar concentration. Likewise, in your base as well, that we have OH minus. OH minus, you know, it is also a ion, right? But it is that of negative ion. So in that same note, if they give you the value for OH minus, the value for OH minus, know that they're actually talking about concentration as well. They're actually talking about what?
Concentration.
And what kind of concentration are they talking about? They're talking about molar concentration. Are we together?
Yes, sir.
Are we at the same time? Now, let's now actually go to the pH. To the pH that have you written it down? Please note it down. Oh.
Yes, sir.
So now, the pH, the so-called pH, we said it is potential of hydrogen, while pH is potential of what? Hydroxide, right? So I'll now give you different formula for pH. Now, I gave you one in our last class. I said pH is defined. pH is defined as the what? As the negative logarithm of what?
Of hydrogen ion.
Hydrogen ion to base 10. Are we together? So now we also have POH. POH. POH is, who can define POH for us? POH. If we define pH as negative logarithm of hydrogen ion to base 10, who can define POH for us now?
Logarithm of hydroxide ion.
It is negative logarithm of what? Hydroxide ion to what? To base 10. Are we together? So that's actually the definition of pH and POH. Now, don't forget that we have the pH scale, right? And the pH scale runs from where? From 0 to what?
14.
14. And we have a neutral of what? Of 7, right?
7. Yes, sir.
Now, this one is ion. This one is ion, which is in concentration, Abby, and we said it is molar concentration. This one is in ion, Abby, which is also in concentration, Abby.
Molar concentration.
Now,
Yes.
molar concentration. Thank you very much for that. Now, this one is actually neutral number. What do I call it? Neutral number. Now, like 1, 2, 3, 4, 5, to what? To 14. Are we together? Now,
Yes, sir.
this is
Yes, sir.
this pH measure that of the acidity, which is acid, because hydrogen ion is from an acid, right? While POH, we measure that of the base. Are we together?
Yes, sir.
Yes, sir.
We measure that of the base.
Yes.
And yes, it measures that of the base. Why this one will also be in concentration as well. Are we together? It will be normal number. Who can tell me what will be the range value of pH that we should have? The range value of pH that we should have.
0.9.
Thank you very much. It will be from 0 to 6.9. What of POH? Will be from 7.1
7 to 13.9.
14 to 14. Let us say to 14. This one will be 0 to 6.9, while 7.1 to 14. Are we together? So that shows that any value you must get for the pH must not be greater than, must not what? Equals to 7. Must not equals to 7. If perhaps it is equal to the 7, it means you get your value to be what? Neutral. Are we together?
Yes, sir.
It is neither acidic nor basic.
Not
Basic.
basic.
Are we together for that 7? It is neither acidic nor basic.
Basic.
So that's all. That's all we need to know. So have we written the formula down? So we want to write another thing. So now we know that we have pH, Abby,
Yes, sir.
and we said the value should be from 0 to 6.9, right?
Now,
And
Yes,
pOH as well. When you have pH plus pOH, who can give me the actual volume that both of them should be? They should be equals to what?
14.
Normal scale. Normal scale should be equals to 14. Are we together?
Yes, sir.
That shows
yes,
that
sir.
pH plus pOH should be equals to what? 14.
14.
They must not be more than 14. Addition of both of them should be equals to what? 14. Are we together?
Yes, sir.
Yeah. So another formula we should also know is when we have concentration, OH, H minus plus H plus, both of them should be equals to 10 raised to power.
H2.
Yes, both of them should equals to 10 raised to power minus 14. They should be what? 10 raised to power minus 14. These are the 3 formula that we need for pH scale calculation. Are we together?
Yes, sir.
Yes.
This is what we need. This is what we need. For what? For pH scale calculation. Have we written it down?
Yes, sir.
Yeah, okay, someone has a question? Any questions so far? No question, right? Should I clean the board?
Yes, sir.
Should I? Okay.
Yes.
Let me see if we can have a question on pH. Okay, fine. I want to share you one question. Okay, let's go with this question. Can we see the screen? This question number 2. They said, what is the pH of a solution with H plus hydrogen ion equals to 1.0 times 10 raised to power minus 3 molar? You see that this is capital letter M. Okay, it is your, you cannot see it very well, you can't see it.
You are saying it, bro.
No, someone's messaged me now that I can't see the screen very well, or you cannot see it at all. If you can't see it, you need to log out and relog in. It's your network.
It's network. Check your network.
It's your network. So you log in and you relog in, log out and relog in. Let's write the question down, or let me just call the question so that you can write it. You can. What is the pH of a solution with hydrogen ion? With hydrogen ion, which is with hydrogen ion, you see that we have a bracket. And I told you that when we have a bracket like this, they're actually talking about concentration, right? Are we together?
Yes, sir.
Yes.
Yes, sir.
So we have 1.0 times 10 raised to the power minus 3 molar. And molar, what does molar mean? Capital letter M, molar. What do we call it? Someone talk.
Concentration.
Molar
Concentration.
Yes, yeah, they are talking about molar concentration. So we are given the H plus to be what? 1.0 times 10 raised to the power minus 3, right?
Yes, sir.
They ask us to calculate. Yeah, let's go with it. Now, before we can go, we need to know some things offhand in our head. We need to know it. So, for example, log, without, we won't use calculator while we were dealing with this thing, our jam. So, log 2 base 10, you need to know it offhand. What is log 2 base 10? Log 2 base 10 is 0.3010. What do I call it? 0.3010. You need to know log 3 base 10. Log 3 base 10, you need to know it offhand. It is 0.477. 0. What? 477. Yes, exactly. And you need to know log 10 base 10. What do I call it? Log 10 base 10. And your log 10 base 10 is equals to 0. It is 0. What? Someone says 0.1. Any number that we have to the base of that number, it is equals to 1. Even if you have log 2 base 2, it is equals to what? 1. Are we together? So these are the things that we need to know. If you know this, if you press it in your calculator, you still get the same thing. Log 2 base 10 is equals to 0.3010. Log 3 base 10, 0.477. Log 10 base 10 is what? 1. Okay, can someone tell me log 4 base 10? What would be log 4 base 10? Okay, that means that we still need to go to our mathematics. So in logarithm, when you have logarithm, what you need to do is that when you have logarithm, something like logarithm like this, for example, log 1 of logarithm, when you have log A times B, log A times B, it means log A plus log B, just like your laws of indices. Are we together?
Yes, sir.
When you have log A times B, it means what? Log A plus what? Log B. Are we together? When you have log A divided by B, what does it mean? It will be what? Your log A minus what? Minus your log B.
Log B.
Are we together? And when you have log 4 base 10, is same thing as log 2 times 2, right?
Yes, sir.
And log 2 times 2. Are we together? And log 2 times 2 can be what? Log 2 base 10 plus what?
Log 2 base 10.
Log 2 base 10. Log 2 base 10. And your log 2 base 10 is what? What do we give us for log 2 base 10?
0.3010.
0.3010 plus 0.3010. What are we going to get?
0.6020.
0.6020. If you press log 4 base 10 to your calculator, you still get this, the same thing. Are we together?
Yes, sir.
Do we need to write it down?
No, sir.
Oh yeah, let's write it, please. Let's quickly write it. We don't need all these. We just need to go straight to the to our this thing. Are we together?
Yes, sir.
Okay, are we done? Are we done with it? Yeah, let's be fast. Are we together? So are we done with it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
You've done.
So now my question is this: we can actually work this out. If you were given, you were given log 2 base 10, the number, right? And you are given
Yes,
log
sir.
10 base 10. Can we find log 5 base 10 from this? Can we actually find log 5 base 10 from this?
Yes, sir.
Are you sure we can do that? Oh yeah, let's go with it. Yeah, can we do it? You want to find log 5 base 10. And don't forget that log 5 base 10, we can actually say it is log 10 divided by 2, right? Are we together?
Yes, sir.
Do we get it? Do we all get it?
No.
Are we on the same page?
Yes, sir.
Oh yeah, what's your question? Okay, Yusro Lawal. Do you have any question?
No, sir. But the answer
Okay.
of log 5 base 10 is 0.7880.
We don't need to press calculator. We don't want to press calculator. We are not using calculator. We are
I
not
did not
using
use calculator.
calculator. You not use calculator. You know it offhand.
Yes, sir. No, I
Barakallah.
just calculated.
You just calculated it. Okay.
Let's try it.
Now, oh yeah, let's go with it. So we know division we change to minus, that be subtraction, right? You can say
Yes.
minus, right? Log what? Log
Minus plus
2.
5.
2.
2.
Abi? And log 10
Yes,
base
sir.
10 is what? Log 10 base
1.
10 is
1.
what? 1
1.
1.
minus what's our log 2 base? What's our log 2 base 10?
0.301.
0.310.
0.310. Oh yeah, what will now be your answer?
0.
Point 699. I just calculated it, so
0.969.
it's 0.969.
Eh? No.
What's the answer? Subtract it from your offhand now. What's our answer, please? Don't let us waste much of our time. We don't have much time again.
0.699.
0.699. So that's our answer. Our answer is 0.699. So our answer is 0.69. Okay, Alidaya, what's your question?
Sir, can't you approximate it to 0.7 or
No. We don't approximate it. We just need four, what do we call it? 4 decimal places. Do you understand? So if you want to do it, we said it is 0.6990. 0. What? 6990. That's actually what we said. Are we together? So
Yes, sir.
that's the answer that we need. So that shows that we can actually take this thing, we can get our answer if you are given anything. So let's back to our question. The question that we have, what's the question? Yeah, someone should read the question for me, please.
What is the pH of solution with H plus equal to 1.0 times 10 minus 3?
They said what is the pH, right? We don't know the pH, Abby.
Yes, sir.
They now give us hydrogen ion to be what? 1.0, Abby. Times
Yes,
what?
times
Minus
10
3m.
What is the power?
Minus
minus
3m.
3m.
Minus 3m. We don't need this thing. 1 times 10 raised to power minus 3 is the same thing as 10 raised to power minus 3, right? Are we on the same page?
Yes, sir.
Are we together? So definitely we are on the same page. So me, I've known the answer now without calculating anything. I've known the answer by myself. Okay. Now, in logarithm, when you have a raised to power 2 log a raised to power 2, these two will come to the front. These two will come to the what? To the front and becomes what? 2 log a. Are we together? 2 log a. Are we together?
Yes, sir.
Yes, sir.
So
Yes,
in
sir.
logarithm, when you have log a raised to power 2, these two will come to the front and becomes what? 2 log what? Log a.
A.
Are we together? We've known
Yes,
the
sir.
hydrogen ion. And from the formula of our pH, we said pH is what? pH is negative
Minus log.
logarithm
Minus
of
log.
hydrogen ion. What?
Hydrogen on
To
base
base
10.
10, Abby?
Base
To
10,
base
yes,
10.
sir.
You've been given your hydrogen ion, Abby. What's the hydrogen ion? 10 raised to power what?
0.3.
Minus.
The 10 raised part 3.
It is 10 raised to power 3 or 10 raised to power minus 3?
Minus 3.
Minus
3.
Minus 3. So now our pH will now be equals to minus logarithm minus log. What is hydrogen ion? 10 raised to power minus
Minus 3.
base what? Base 10.
Base 10.
Now this is minus 3. According to what we did earlier, that when we have log a raised to power 2, the 2 will come to the front. Abby, likewise,
Yes,
this
sir.
minus 3. Minus 3 we need to come to the front here, right?
Yes, sir.
Yes.
And become what? pH will now equals to, don't forget that we have minus before.
Plus.
We have minus here. We have minus. This minus 3 will come to the front and becomes minus 3.
Minus.
Abby,
Yes,
Yes.
sir.
log what?
Log 10.
Log 10 base
10.
10. Abby,
Yes.
Yes, sir.
Yes.
are we together?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, you're on the same page. So I want to continue here. So now minus times minus will give you what?
Plus.
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 We have our pH to be equals to plus 3.
Thank
Oh,
you.
10 is 10.
Log 10. Log 10.
Log 10 base 10 is equals to what?
1.
1.
1.
That's it will now be 3 times 1, right?
Yes, sir.
Yes.
It will now be plus 3 times
Yeah.
1. And 3
Yes.
times 1 will be equals to what?
3.
Plus 3.
3.
So plus 3, we have 3.
3.
So our pH equals to 3. Is it now acidic or basic?
Acidic.
Acidic.
Are we sure it is
Acidic.
acidic? So
Yes.
if they ask
Yes.
us that the pH of 3, we know it is what? Acid. Are we
Acidic.
together?
Yes.
So you put it down. So that's the answer. So now let's now go back to the question. If we have, this is the question. This is the question. Do we have 3 in the option?
Yes.
Yes, sir.
Yes, sir.
Option.
This is our answer. So 3 is our answer here. That's all. Why do we have 3 as our answer? Let me just give you shortcut. You know it is 10 raised to power minus 3.
Yes.
10 raised to power what? Minus 3. And this one is 1. Right? Whenever
Yes,
you
sir.
have 10 raised to power minus 3 or 10 raised to power, if you have 10 raised to power minus 3 and you have to calculate pH, the answer you must get is 3. If you have 10 raised to power minus 4 and you have to calculate the pH, the answer you are going to get must be what?
4.
Except when you have, if you have any number that is slightly different from 1 here, you know, because 1 times this will actually give you that number, right? That is why
Yes.
have our answer to be minus 3. If the number that is here is 2, we cannot get minus 3. If the answer we have here, it is 2, we cannot get minus 3 as our answer. We need to work it out. Are we together?
Yes.
Yes, sir.
Now, can someone now tell me the answer for this? If your pH is equal to 8, who can tell me the ion concentration that we are going to get? You know, our pH before is 3, and the answer, the question that we were given is 1.0 times 10 raised to power minus 3. Abi,
Yeah.
now
Yes.
our pH now is 8. What will now be our
1.0
answer?
times 10 raised to power minus 8.
Minus 8. We are going to get 1.0 times 10 raised to power minus 8. So that's all. We don't need to work it. We just need our logical reasoning to get our answer. Are we together?
Yes, sir.
So any question? Do you have any question? Yeah, just write it down, pen it down. So
We can stronger food.
I can't hear you very well. What you said?
Don't talk about the strong and weak acid that I have.
Please speak aloud. Can someone hear what he's saying?
No, sir.
Okay. Recap,
Talking
my
about the
brother.
strong and the weak acid that we are
He
talking
said the
about.
strong acid and the weak acid.
The strong acid and the weak acid. So,
Yes, that was
yes.
what I heard for me.
Is that what you said?
Yes, sir.
You said how do we identify weak and strong acid, Abi?
Yes, sir.
Okay. Now, how do you identify them? I said it that from 1
to 7.
to maybe like 3.5, they are still strong. But if you have 3.5, it is slightly strong. Slightly strong. From 4 to 6. What's it called? 6.9, they are weak acid. They are what? Weak acid. The acid are becoming weak. That's why I said that. Have we written this down? Have we penned it down? So on the pH scale, now we said that we have 0 to 14, and we said this 7 is neutral, right? So
Yes.
from here to this, that's increasing an acid. That shows that here, this position is weak acid. This is weak. This has becoming strong, small, strong, slightly strong, and these are strong. Are we together? So likewise,
Yes.
these are the weak base. These points are the weak bases. And when you reach this side, like 11, it has becoming slightly strong. Strong, become strong, perfect. Are we together? That's how we measure it. Are we together?
Yes, sir.
So that's it, my brother. So any other question?
No, sir.
No question.
No.
Do you all understand what we did today? Do you all understand?
Yes, sir. Yes, sir.
Okay. So far, there is no question. Thank you very much once again. So thank you for your cooperation. So, inshallah, we are going to have our test for this. I'm going to set a question on this. So we are going to have it in our next class. Inshallah. So,
Thank you, sir.